Hello guys again. So we now come to the next experiment, which is on loading some data written into the RAM. And to do this, we are going to write an assembly level program. So our work again is split into two different parts. Let's look and understand the logic that you really have to use when you are loading data into the RAM, and how to implement this logic into R. Let's understand this. So we really don't have much of what we can call as an algorithm, because most of this work is simply just moving data into the RAM. And when you are moving data into the RAM, you are actually talking about memory. So we are only going to deal with memory addresses, and instructions and assembly directives which are required for doing this operation are of concern in this program. So more than the logic, it is these directives and instructions that we are going to focus on. And to not make things very complicated, I am directly going to go into the program and show you how it is done, so that you can try more things on your own. Now here is what is the code that we are going to use. So we are going to use this piece of code where we have introduced two new terminologies. So the first part of your code remains the same. You are going to create a program area, create an entry point for the program area, export the name of this program area as move data RAM, and within that we are going to create a variable called as data, and that data variable we are going to load with some value. So this is the value which we are loading into the data variable. So here we are using an assembly directive which is called as dcd. Okay, so the dcd is basically the assembly directive for loading or data can actually be loaded into this particular this one. Now dcd is simply equivalent to nothing but the equal to operator, the regular equal to operator. So what we are saying here is nothing but data is equal to 458 whatever that number. So we are simply saying that this number is loaded in is equal to this data. So this is an assembly program. So this is the easiest way of writing that equal to operator. Now after that we are going to start our program segment. So in the program segment we are going to load the value that is there in this location. So we are actually initializing one memory location with a name called as data, and into that memory location we are putting this value. So that value is going to be loaded into R0. Then also we are going to initialize one more memory location, and that memory location we are going to add the value 0. We are going to create one memory location and we are going to add the value 0 into that. So this memory location is initialized to 0, and when we add this equal to operator, the equal to operator is basically saying that you have to use the address, load the address of the location which I am calling here as RAM block. Remember this, when I put the equal to operator here, it simply means it is going to return the address to this. So it is like a pointer that we use in the C program. So when you add the star is going to tell that you are talking about the address of this variable, not the value that is stored in the variable, but more importantly the address of the variable. So the same difference exists here also. In this case, we are talking directly about the value, but here you are talking about the address. So the address is actually stored into R1. So now we are going to move the value from R0 into the address which is pointed by R1. So to tell that you are talking about the address pointed by R1, you have to enclose them within square brackets. So enclosing your variable within square brackets simply means that you are not talking about the variable itself, but about the address that is pointed to by that variable. So this entire thing is actually done in only these three instructions. But for doing that, we have to remember to initialize the variables that we want to use. So the first variable we initialize is data DCD. Second one is your ramlock DCD. Okay, and we have to create a separate area for the RAM. So that is why this portion is written separately. So this is a separate piece of code that is written in a separate place, which we are calling as our RAM. So a separate piece of memory which we are calling as RAM. This was written for code, and this one we are writing for data. So into this, here in this area, we are initializing a location and clearing that location with this instruction. So this instruction is actually clearing this location. Okay, so quickly let me summarize. I understand this is something very new, so let me quickly summarize what we have just now done. We've written two different memory locations. In one memory locations we've loaded the program, in another memory location we've loaded the data. In the program area, we have defined a variable, and into that variable we have assigned one value. So we have added one value into that variable. That is nothing but we have taken one location, memory location, and into that location we have loaded this value. Now after that, that value itself was loaded into R0. Similarly, we have created one more variable, but this variable is created in another area of our memory, and that memory we are calling it as RAM. And in this place we are creating one location called as ramlock, and we are clearing ramlock. We are keeping it 0 in the beginning. And what we are basically doing is we are bringing the address that is pointed out by ramlock, the address of ramlock, we are putting it into R1. And finally, we are using the store instruction to push whatever value was there in this variable into the address pointed in R1. So this is the working of these three instructions. So enough with theory, let's now see what it actually means in practice. So I'm going to execute this program for you. Let's take up the program. I think I've already typed it. Yeah. So we have the regular C program, the main program again, okay, where we are going to call our external function, and that external function is what we have written in the program segment of this memory. So this entire segment is separate. It is the program segment. This entire thing is another segment which we are calling as the RAM segment. In the program segment, we have loaded this value into a location which we are going to call as data throughout this program. And we have one more location which we are calling as ramlock, where we have loaded the value 0. Okay, so let's see what really is going on here. Let me compile this. Okay, we are good to go. Let's put it into debug mode. Okay. So let's see what really happens till here. Okay, I will show you them one by one. Okay, so initially there is some value loaded here. You can see that R0, R1, R2, all three of them have some value. R3 is something else. Let's execute and see what happens now. So now initially R0 got the value, some hexadecimal value got loaded into R0, right? So I'm going to execute it for one more time, and R0 got set to the value that we have put in the data. So this instruction got completed and this value got loaded into R0. Now let's see what is there in ramlock. So ramlock's value is getting loaded into R1. More importantly, the address of ramlock got loaded into this place. So that means this is an address in your memory. So what is the value? 2007 C 000. That is the address that is there. And let's see what is there in this address. In this address right now, nothing is there. It has got cleared. It has become 0. Okay. So this is the value that is there in this place. Now, what we are going to do? We are going to store whatever is there in R1, whatever is there in S1, into from R0 we are going to push it into this address. Remember, str instruction uses the opposite format, that is this one is the source and this one becomes the destination, unlike our previous instructions where the first part is always going to be the destination. In the case of store, this portion becomes the destination. So I'm going to push this value now. So when I execute this, what really happened was our value that is there in data, that is 45856812, that entire thing got pushed into this address. So this address we have the value coming here. But notice how it is stored. It is stored in reversed way. Okay, so 12688545. That is how it has got stored. Okay. So the entire storage value is going on in reverse way. I hope you look up why it is in the reverse way. This is a very interesting question. It is something that you have already studied in the theory classes. So please look up why it is stored in the reverse way. That is a question that I'm going to leave to you guys, which we can again discuss during the Viva VC. So I hope you have understood this. To show you another variation of the same program, instead of putting 0 here, let me load, how many F's are there? 4 and 4, 8, right? So let's see what happens now. I'm going to build this again. Okay, so yeah, so now you can see that R1's value is starting from some other address, 2007 C00 C068 is the memory location that you are looking at. Okay, so this is the memory location that you are looking at. Okay, so now when I ask it to start running the program, you can see that initially it is 0. Now I ask it to run the program. Okay, so initially data value is supposed to get loaded. It got loaded. Okay, now RAM block, we have to ask it to load. Okay, okay, now the value here has changed to 2007 00. So again when 00 only, the value has come. Okay, so let's reset it and let's run it again. Okay, this one got loaded. 2007 C00 is loaded with FF. Okay, right? So 8 F's have actually been loaded into RAM block. Now on execution of store instruction, that will be loaded with the value that was there in data. I hope things are much clearer here. So this program, we are entirely only using two different instructions, that is your LDR, that is load register, and your store register instructions. And we are using these assembly directives of area DCD, both of which I think you should become familiar with. If you are not comfortable, you should become familiar with them in this program. So on that note, and finally, I think I gave you one more interesting question, that the values when they are getting stored in reverse order. So why are they getting stored in reverse order? So this is something that you have to explore, and giving you a quick preview of this, I hope you can carry forward things here. So on that note, I am going to wind up this session. See you guys then.